Question 21I. Yep. Suppose that A is a real number and that W is equal to A minus I. Express the following in the form of X plus IY, where X and Y are real numbers. I, omega, and then conjugate. Cool. Again, as always, when I teach a question like this, that's meant to be a little bit more, let's say, logical. I'll always ask you, what would you do? So you'll realize hopefully that you'll be able to answer it yourself. So Sashenka, what would you do for I? What's your thinking process?
So I times A minus I.
Yeah, right. I would think so too. So it would be I times A minus I, which becomes A I and then minus I squared, which is plus 1.
Yeah.
We don't like it like this. We usually write them in this form, right? Like, real at the beginning and then imaginary at the end. So let's just, so we don't get ourselves confused, let's swap it around. But, that was just IW. And if you wanted IW conjugate, what's the answer?
I got AI minus 1.
Of course, because you didn't do what I just did.
Yeah, yeah.
And what should it have been?
1 minus AI.
There we go. There we go. Simple mistakes. Okay.
Yeah.
Conjugate changes only the I, and that's probably why I showed that line, because you're still practicing until you're a bit more comfortable. Maybe in 2-3 weeks time, yeah, you would just know negative AI plus 1.
Yeah.
Either two. Anyways, rub it out. Next question.
31I.
31I. Let Z equal to A plus IB. Find the imaginary of 5I minus ZI. Firstly, do you know how to read that? The way I just read it, like imaginary of?
Yeah.
Yeah, cool. So like this one up here is just saying conjugate of IW.
Yeah.
So that's why you did this first and then you found the conjugate. This is asking for the imaginary of, but you don't even have this yet. So first thing we got to do is find 5I minus ZI, which equals 5I minus A plus IB I.
Yep.
Which equals 5I minus AI. That becomes positive I squared B. But then that becomes negative I squared B. So therefore it's positive B. Don't do it as fast as me if you don't feel comfortable doing it like that.
Okay.
If you feel like you're ready, then go for it. If you don't do it.
Yeah.
All good so far?
Yeah.
Now if I ask you what's the real of this, whoops, what's the real of that? You would say?
B.
Yes. Now careful. Imaginary. Imaginary of 5I minus ZI. You would say
5I minus A. Oh, 5 minus A in brackets I.
Close. So close.
Oh.
I knew you would say something, and that's why I probably tried to say be careful.
Wouldn't it just be 5 minus A?
Can you tell us why?
Because why would you put the imaginary with another imaginary in it? I don't know how to explain it, but like...
No, I can't give that to you. Your answer is right. So he's saying this. It's just 5 minus A. Can you tell us why that would be the answer?
Well, it's just the imaginary.
The coefficient of...
Essentially, say it again.
The coefficient of the imaginary bit, I would say.
I like that a bit more. Yes, I would have accepted that. I is just telling you location. Don't forget that. So if I tell you what's the imaginary part is just the 5 minus a. It's like me telling you this, right? Think of, you know, a lot of your high school career, you've learned coordinates, x and y. So if I said x is b and the y part is 5 minus a, if I asked you, hey, what's the y part? You wouldn't have said it's 5 minus a y, right? You would have just said this term.
Yeah.
So this, in this format, is trying to tell you the location of this term and the location of this term in this format. But when we're writing them as complex numbers, if I didn't have, sorry, not y, if I didn't have the I, it would look like this, b plus 5 minus a. How do I know which one's x and how do I know which one's y? I don't. And that's why there's that I business. So the I is just trying to tell you this is your y coordinate. This is your x coordinate.
Yeah. Okay.
That makes sense? So it's just location. So if we're telling you what's the imaginary part, we're only looking, we already know technically, you know, now these are the I's, so you can ignore them. We're only looking at the imaginary components. That's what you're doing when you're saying equate imaginary or equate real, same thing.
Okay. Yeah.
It's like saying equate, you know, y's. Again, you wouldn't introduce y's in there. You only look at the y values. Similar
Yeah.
concept. Yeah, good. Good. That's fine. Obviously, you now know the answer. 5 minus a.
Mm-hmm.
Cool. What else?
The second part of.
But now you know how to do that because that's
Yeah.
exactly the same as the top one. You might have made a similar mistake.
Yeah. Yeah.
Times it by I, times it by 4, and then write it properly, and then conjugate.
Yeah. And then I was having trouble with 40.
Yes, I did that on purpose. I just wanted to make sure we didn't do any of the proofs. I just wanted you guys to first try out some proofs by yourselves and see what you can conclude. 40. Let z equal to x plus iy, where x squared plus y squared cannot equal to 0. You will see why in a second. That needs to hold true. Continue. Show that if imaginary part of z is greater than 0, then imaginary part of 1 on z is less than 0. I feel like, Sashenko, you can do this now for some reason, right? What's the imaginary part of z?
Y.
Good. So essentially it's telling you, this is telling you
That y is greater than 0.
beautiful. That's what it's trying to tell you. It just looks fancy. Sounds good?
Yeah.
Then we're hoping that the imaginary part of 1 on z is less than 0. But what is 1 on z? See, it looks very hard. Your eyes look at this and like, oh, you just got to relax and go, okay, imaginary part of 1 on z. So what is 1 on z? Go. What am I going to write next? Yep.
1 on x plus iy.
Yep. Then what are you going to do?
It's greater than 0. Less than.
No. Think complex numbers in the bottom.
Conjugate.
Conjugate. Good stuff. What do you reckon? Sashenko makes sense. What he's just done?
Yeah.
Good. Then what do we get? We get x minus iy on. What should the bottom become? Does anyone know how to explain that quickly?
X squared plus y squared.
And that's why they had to give this condition. Right? You don't use it, but that's why that condition has to be there, because if that's 0, there's a problem, right?
Yeah.
So that it's trying to tell you it's not 0, so just continue. Now we have a complex, just out of curiosity, actually, we've got this. Can somebody tell me how to write this in real plus imaginary? How would I write this as real plus imaginary? I just want to make sure you guys know what the real part of all of this is.
Would the
X.
real be?
Oh, sorry. Sorry, Julia, you go.
Oh,
So
okay.
there you go.
Would the real be x over x squared plus y squared?
And then what would be the imaginary part?
The minus y.
Mine is just y.
Oh, over. Sorry. X squared plus y squared.
And do we include the I or no including the
Oh, I thought we included the I.
I? Yes, we include the I.
Oh, okay.
Because we're writing in that form. I'm not telling you right now, I haven't said, hey, which one's the real and which one's the imaginary. We're just writing in that form, the A plus IB form, Cartesian form, right?
Yeah.
Good. I'll pause there. Any questions so far?
No.
So Shanko, when you looked at this at first, you were like, whoa. But now when you realize, okay, imaginary Z, I just went, oh, well, what is it? It's Y. Then I mean, well, that just means Y is greater than 0. That's all I can conclude from that information. Next, imaginary part of 1 on Z, but I don't even have the 1 on Z yet. So let me do 1 on Z. Hopefully you remember, yes, conjugates. You get to this stage, and then maybe you might split it, you might not. It just depends on, how good you get to see your reals and imaginaries. Then if I ask you what's the imaginary part of 1 on Z, now you would say,
Y, negative y on x squared plus y squared.
and you are hoping to somehow say that that is less than 0. Can you guys put everything together now and conclude why this must be less than 0?
Because x squared plus y squared cannot equal 0. And there's negative on the y.
You kind of said it right, but not perfect.
Okay.
You're very close again, but not perfect. So I'll tell you a counter reason for what you've said. You said x squared plus y squared cannot equal to 0, which I like. But what if it was negative? Does that mean a negative over a negative gives me a positive, and all of a sudden that becomes a positive number? So there has to be something else you've got to say other than just cannot equal to 0.
When a number is squared, it can't be
There
negative.
we go. So what you want to say is actually x squared plus y squared is
Greater than 0.
yeah, greater than 0, because they're both squared and they're both adding. In fact, that's just greater than 0. So the bottom is always positive. And what do we know about y? Y is also always
Negative.
y, just y itself.
Greater
Yep.
than.
Yeah, so y is always positive. But then when you put a positive number with a negative, it's always going to become negative. So y is greater than 0, so negative y is less than 0. Therefore, imaginary of 1 on Z is less than 0. We need to have something here. You need to tell us why you concluded this was less than 0.
Okay.
Makes sense? Otherwise, again, what if y was a negative number? If y itself was negative, and a negative all of a sudden makes this whole thing into a positive. But y isn't negative, y is positive. Does
Yeah.
that make sense?
Yeah.
Cool. Otherwise, what do you think of the math? Pretty
Easy.
straightforward. Yeah. I think you can get the hang of this. And it's usually, honestly, give or take, they're the same concepts. Give or take. We'll do another one now. They're not related, by the way. So that's one done. That's another one. Let's try double A. The modulus of 1 on Z. Modulus of 1 on Z equals modulus of 1 on equals, oh, this is going to be fun. All right, equals modulus of, we've already converted this. I'm just going to use it. So x minus iy on x squared plus y squared. Is that okay?
Yep.
Everybody? Any questions? Then we have to find the modulus. So let's see who's going to say this part right. Give me the general formula. Forget this question. Just give me the general formula for the modulus. How do we find it?
Square root a squared plus b squared.
And can you tell me what A and B represent real quick?
A is real, b is imaginary.
Good. So then what is A and B in this case? Yes, it's annoying. I know. So what's A?
Oh, sorry. X over x squared plus y squared.
And then squared plus, and then same thing. Cool.
Oh wait, doesn't matter.
Now this comes down to, again, your algebraic skills. How good are you at algebra? Me, because I know, wow, this can modify in so many different ways. I wouldn't expand this just yet. I wouldn't. Because remember, you're trying to prove the left-hand side equals the right-hand side. So what I might do is just pause. You would pause there, and you would try to see what the right-hand side became. Maybe you can leave a few lines. I might just do the right-hand side here. Right-hand side, which is 1 on. You understand what I'm trying to say there, guys? So I would say you don't know where you want to get to with this. You don't know, it wasn't a, hey, show 1 on Z modulus equals to, like 10. If it was, then I would have continued. Because it's a right-hand side, left-hand side question, I don't know. Maybe if I just did my right-hand side, I can just get to that and I say I'm done. We understand my thinking process?
Yeah.
Cool. Okay, so then, and I'm telling you exactly how I would do it in an exam. Like, I actually would stop. So 1 over modulus of Z. Well, the modulus of Z is, as Julia said, just going to be square root of x squared plus y squared. There. Which definitely doesn't look like this guy, right? But at least now I know exactly where I need to get to. So let's play with this a bit. If you don't like the modulus, if you don't like the square root, just square it on the left side, on the left, and then you'll only deal with the brackets. Because I don't mind them for now, they're not bothering me. We'll just leave it like that. All right. Can somebody tell me what they would have written before I tell you what I would have written in my next line? What would be your next step? Just so you can see if it's right, if it's wrong.
I would have written x squared plus y squared on top of x squared plus y squared squared.
Yeah, I love that. That's perfect. Maybe even a little bit faster than what I was about to write, but perfect. I might have left them just separated in case it was hard, but if you can, good. Do we all agree with what she's done? She's realized common denominator, so we might as well have it like that, and then x squared plus y squared squared on the top. Remember, we have the answer. Anyone can see the answer already?
Yeah.
Cross. That becomes square root of 1 on, and we got it, equals right-hand side. You don't need to simplify it anymore. We can all see that's the same. See, that's a very, very important skill to learn. I mean, it's got nothing to do with your math. It's just an actual skill that you need to learn. Doesn't matter if you're doing extension 2, extension 1, advanced. It's a skill to be able to stop and go, okay, let me work on something else. What do I actually want? And then come back and finish it up, because it gives you a bit of guidance with what you want to do. Not always about just running into it and just going all crazy and finishing everything off. It's not always the smartest option. Okay. Rav, kept up with everything?
Yeah.
Okay. Next question then, I guess. What's the next one?
That was it from me.
Yep. Anyone else? Any questions? Caleb, I know you said you might have had one or two.
No,
Maybe
that answered all the
32
questions I had.
I.
yeah, they've been answered. And what did you say, Rav?
32 I.
32 double I. What was your answer for I? If you don't mind. 32 is maybe
Let's
negative.
hope I wasn't wrong.
Sorry?
Oh wait, I don't
Something
think I
like
did
that.
it. I don't think I did it. I think I just skipped it.
Okay, but do you know how to do modulus argument?
I forgot, but it's alright. I'll just catch up on it later.
There's never later. You won't have time later. Wrong. What's the modulus? How do I find the modulus? Rav. Square
A
one
squared plus,
squared.
oh,
Yeah. X squared plus y squared. Done. How do I find the argument?
this.
Inverse tan
Oh yeah, I knew that.
B on A. Because you haven't done your homework, you realize
Okay.
yeah? Careful, man. You don't want to fall behind in this subject. Believe me.
Yeah.
Pi 4. Then what do you have to always do for mod arc form? Check
Draw
where
it
it's
up.
at. Yeah, so 1 minus I is somewhere there. We know that's a negative theta, so therefore the answer is actually negative pi 4.
Yep.
Make sense? And then if I'm going to go to the power of 2n, you would never do that because you actually can't expand that. What you would do, you would get this thing and go power of 2n.
Oh,
Yeah, and then it's just that's the 2 to the half. So 2 to the half times 2n, because that's what you do with your index laws. Is that right?
yeah.
This is negative 2n or 2 pi n on 4.
Yep.
Technically, the final answer will be, half and 2 is cancelled out, so 2 to the n. This is negative pi n on 2. Make sense?
Yeah.
Seriously,
Yeah. It makes sense.
100%. All right. Please, Rav. I know you're the only one that doesn't have their HSC on the line for this because you're 1 year ahead. Still, you've got to take it seriously, man.
Yep, Sam.
And Queenie, I think it's Queenie's probably what? Queen, is this our third time doing this? Second time? Third time? Second time? Third
Yeah, I think second.
Second? Yeah. So, and she took it really seriously the first time. So, just saying, you guys, please, Rav, take it seriously. Full stop. All right.